Hi, in this tutorial I'm going to talk about additive synthesis. This is a very simple drill. I'm going to show you how to build classic waveforms such as triangle, sawtooth, square with just sine waves. This is not something we do in real life. We don't make music by adding sine waves just to obtain sawtooth. Normally we just start with sawtooth and filter that out. That's called subtractive synthesis. Nonetheless, this is a very good drill just to get a basic understanding of how additive works, and if you can build those three waveforms yourself, then you can build anything else. And second thing is that with this exercise you can understand the structure of those classic waveforms that you're going to use in subtractive synthesis. So additive, it's good for additive, good for subtractive. So let's kill two birds with one stone. So we are here in VCV Rack. For this drill, I am going to get us 4 oscillators. And obviously, if we have 4 oscillators, by the way, what I did right now is kind of dumb. What you can do is just have one and Command D, right? And that's much quicker. Again, Command and move will help you move them all together. Little tricks. Now, obviously, we need to mix them together, and we need to have output. So audio 8. In your version, you're gonna probably choose built-in output, but I'm recording, so I'm choosing this particular driver. And what I really care about is we need to see this waveform, right? So the basic flow is this: we're gonna connect all of these 4 oscillators to mixer, and then we're gonna listen to this sound and also see it. Now, before we begin, I want to show you something on the spectrum analyzer. So let's have a look at what we're trying to achieve. We're gonna start from saw, and as you can see, this is a spectrum of sawtooth waveform, right? So you can see how they are nicely decaying. We have every harmonic here. We're not omitting anything. So this will be our goal, and sawtooth looks like this, right? So this is classic sawtooth. We're gonna do actually inverse, so it will be ramped down, but it's the spectral picture will be the same. Now, so let's get started. So what we want to do here is we want these 4 oscillators to be connected to our mixer, and our mixer connected to waveform display. That's one thing, right? And this waveform that you guys see right now, we want to hear it too. So I'm a bit cautious because I don't want to be too loud, as you can see. So this is our waveform. Right, it's a mess. Now, when we look at that from this perspective, it's actually it's not a mess. It's just 4 oscillators. I'm going to switch to digital so they don't have any other overtones, and we can clearly see. So you can try it on you can pause this video and try to play around to understand what we're doing here. Now, for this particular drill, I'm going to have fundamental frequency at 100 Hertz, then 200 Hertz, 300 Hertz, and 400 Hertz, right? So harmonic series here, classic stuff. And so this is what we hear. Notice immediately how the sound, is very coherent, right? It's like it sounds like one note, even though we have 4 oscillators here. And the trick here, in order to achieve that sawtooth wave shape, right, is that each of these waveforms, each of these harmonics will have slightly less amplitude, right? Slightly lower amplitude. So basic shape could be something like that, right? And for the first drill, if you guys don't want to go too deep into the subject, I want to show you how to do it just by trial and error and without math or anything like that. So all we need to do now is we need to sync these oscillators to fundamental frequency oscillator and notice what happens. It's pretty amazing. Immediately you get that kind of saw. As long as you have, try different settings here on the mixer, but if you do it right, you will get something like that. And that's as good as we can get with 4 oscillators. You can't get any better. If you want more, you have to add another, couple hundred oscillators here to get that super sharp sawtooth. But so that's the first thing you can do. And if you can get this, then pretty much you're halfway through. Everything else that I'm going to talk right now, it's for people who are interested to go, who are interested in going deeper into the subject and learning. We're going to learn about how to set these values precisely and what it means. Also, we're going to look into other waveforms. Now, if you want to just stop at this point, I just want to mention very important part about square waveform, because square waveform, as you can see, is omitting every other partial. So what we're going to do is we're going to try to recreate that as well. So notice that in order to do that, we would have to also omit 200. So instead of 200, we'll have 300 hertz, then 500 hertz, and 700 hertz. And this is what we call odd harmonics, right? And notice immediately everything looks a little bit like square wave. And again, you can tweak and see if you can find that sweet spot. But you get the gist, right? And with triangle, there's the formula is slightly different, and you have to flip phase. So maybe later we can try doing it, but don't worry about it. So at this point, if you understand this concept, how these waveforms contain harmonics and how to build them, it's a very good start, and it's very useful later on to understand what we're going to do in subtractive synthesizers. So let's now go slightly deeper for those of you interested. What I'm going to do is I'm going to reset that mixer. By the way, in VCV Rack, double click on these attenuators and faders, I would say. And so we are resetting this waveform to all unity gain for all of them. And this time I'm going to go through a module that is called Attenuator. Okay. Maybe I'll just call it 8-vert. Maybe that's why they call it 8-vert. And so before we go to mixer, so mixer right now is only mixing. It doesn't do anything else to our sound. It's just mixing them uniformly. So now this will be our mixer, right? I have control over each partial. And let's go back to trying to recreate that sawtooth wave to understand what is the formula for these precise ratios. So if you set fundamental frequency always to 100%, notice that when I right click I have gain 100%, then everything is in relationship to that 100%. And the formula is very simple. If this is our first harmonic, right, this is our harmonic number 2. So in order to get the ratio of this one, so of this fader, you just divide 1 by number of this partial, which is 2. So 1 divided by 2 is 50/50, right? Or 0.5, so 50%. So if we set this to 50%, we get the proper ratio. Now the formula for the third one would be obviously 1 divided by 3. So we're talking about something like 33%. And finally, 1 divided by 4 is 0.25, so 25%, right? And notice that we get that sawtooth. I know that if you think that if you fiddle more with precise values, you might even get more smooth waveform at this point. But if you trust this formula and go beyond only 8 oscillator, right? So if you beyond 4 oscillators, if you go into 8 oscillator setup and more, you'll see that it will get sharper and sharper, and you can try that on your own if you follow this formula. So remember, 100%, 1 by 2 is 50%, and so forth. 33% and 25, and then the next one would be 20%, and you can keep going. Now, important part is, if you want to do the same thing with mixer, there is a bit of a problem. Let's say we didn't have this attenuator, and we go straight to mixer again from each of these oscillators. Now, if we want to set these values in decibels, you just need to do a little bit of math. So don't get confused why we need this math. The only reason is that this particular mixer does not allow you to set these values in ratios. You just have to set it in decibels, and that's another great exercise. So in order to do that, what you're going to do is you bring a calculator, and later I'm going to show you there's also a website. So what you're going to do is, if you want to calculate the value of the second, obviously the first one is 0. It's the value that we compare all other partials to. The second value is, I lost my calculator, very important. Let's see if I can, whatever. So the second oscillator, let's divide 1 by 2, which is obviously trivial. It's 0.5, right? So we already set it in the previous example. Now, what we want to do is, in order to get decibels, you're going to click this logarithm button over here. I know we don't like logarithms, but in this case we need it. And all we need to do now is multiply it by 20. So notice we have minus 6 dB, almost. So you can set this value, minus 6.02. And you do the same for the rest. So the third partial will be, the third harmonic would be 1 divided by 3. Sorry, it's not 1 divided by 3. Sorry, 1 divided by 3, and then logarithm and multiply by 20, right? So even if you don't care about math, you can always do it at home. Minus 9.5, and if you do it on your own, you can be more specific. You can actually add those extra values here. And so let's do the last one is 1 divided by 4, because it's our fourth oscillator, right? 0.25 logarithm and multiply by 20. Little comment here. Those of you who are in electric engineering and physics and stuff like that, you might have seen formulas for decibels in certain scenarios where you multiply it not by 20, by 10. For now, just trust me. For this, you're gonna do 20, and maybe later in some other video I can talk about more specific differences between these different ways we deal with decibels, and it's very annoying because they're technically there are two standards, but for all of the stuff, for audio, decibels within your DAW or modular synthesizers, we are doing this formula. We're using this formula. So minus 12, right? And that's pretty much it, right? So we can trust that these values are very specific, and the reason I'm showing it to you, because if you want to go ahead and try to make this waveform as sharp as possible on your own, with, let's say, 16 oscillators, then this will be useful for you to know that you're doing the right thing, because once you go above certain values, it's going to be these will be very different, tiny, minute details. So okay, so we covered that, how we calculate that stuff, and finally I want to touch upon one little thing, which is when we go back to the setup with 8-vert, that's when it's useful for certain types of waveforms, and that's a triangle waveform. So if you want to build that, let's connect it again, and these values are reset. So sorry, not that. So the triangle waveform, the formula is just like with square waveform, we are skipping every second harmonic, so we're only using on harmonic. So we need to set it up the same way as we set up the square wave and 700. Right, so 500, 300, 100 fundamental, and the only difference between that is the ratios will be different, and they will be actually flipped. So I'm going to illustrate that. So this is our fundamental frequency. Now, in order to calculate the amplitude of the second one, or ratio, you need to divide 1 by 3. Right, so I don't need a calculator for it, but I think it might be easier just to see what I'm doing. So 1 divided by 3, we're talking about this oscillator, sorry, actually 1 divided by 3 to the power of 2, right? So 3 to the power of 2 is 9, obviously. We don't need a calculator for that, but again, so you need to divide 1 by 9 in order to get that value. Notice how quickly they decay. The first one was 100%. This one will be already 11%. And there is a caveat though. Notice that if I have that 11%, it doesn't look like triangle at all. However, I can go into negative values. So if I do minus 11 on this one, notice immediately we get a triangle waveform, just like something you could get from here. Different frequency. Let's compare it to this one, right? Notice how quickly we get the shape. Just 2 harmonics and 2 oscillators, and it already looks like a triangle. So what would be the third one? The third one would be, the formula is the same. You take the, you divide 1 by the partial number. In this case, it would be, I mean, it's a ratio, right? So if we have 500, so we divide this 1 by 5 to the power of 2. So 5 to the power of 2 is 25, right? So we divide 1 by 25, and this is the ratio here. So we're talking about 4%. Now this 4% goes again. This 4% goes again to a positive value, right? And notice how sound also changed. Yeah, we definitely hear that partial still, even though these values are very small. And finally, if you want to see the last one, then it's this one is it's the 7th, right? We're talking about this one is 100, 300, 500, 700. So 7 to the power 7 squared, right? 49. So 1 divided by 49, and you have 2% more or less. And again, this 2% goes into negative again, -2. You see? And as we keep doing that, notice that this waveform is getting sharper and sharper. So on your own, again, this is another fantastic challenge. You can use a mixer from Bog Audio with 8 output, or you can use this and mix them together. And I think it will be fun for you guys to even try it, to go as far as possible. I think this one is probably a good start. And here you would have to put everything in decibels, but you can, I think it might be much more convenient if you want to try. So as you can see, the formula is you're flipping the phase of even harmonics, right? In this case, and the result will get closer and closer to triangle waveform. And let's see. Yeah, so why is it important? Because as you can see, in every oscillator, we have those four classic waveforms. I think it was one too much. Those four classic waveforms, and I really think people should always remember about the difference between sine wave and those three, and what they mean. As a general rule of thumb, I have too many modules, as you can see. All right, so as when you look at saw is the waveform with the most material to work with when we go into subtractive synthesis. So remember that this is the richest waveform you can imagine. We're not skipping any overtones. Square waveform is skipping every second, but the decay is how they decay is the formula is actually the same as in sawtooth. And finally, triangle wave. Very quickly these harmonics decay, and we're also skipping them. So this one is always the most mellow sounding. So I wish they could be maybe ordered in a different way. It should be sine wave, triangle, square wave, and saw as the most aggressive in sound, right? So from the least aggressive to most aggressive. And that's it. Hopefully you will have a chance to try these things and hit pause whenever you need and try to copy some of those setups. And I really encourage you to try on your own, build those larger structures to see if you can get as close as possible to that shape. And finally, little hint, notice that in my example, we were doing ramp down on sawtooth. If you want to do ramp up, obviously you can use Attenuator on the mix just to flip it, but to keep the phase of the original oscillator, so they are all in the same phase, you need to flip every second harmonics. You need to flip the phase of every second harmonics, just like we did with triangle wave, and you will get that ramp up. So that's a little hint. Don't forget that when you work in VCV Rack, you want to use digital version of this VCO. All right. Yeah, that's it. Enjoy.